Okay, geometry class, this is going to be the first lesson of the year. We are going to go into your workbook to lesson 1, constructing an equilateral triangle. If you missed class, this is a great way to get caught up, or if you just want to review what we did before you jump into that problem set, that would be fine too. So the first thing we did in class is you spent 10 minutes, filled in the terms that are on the bottom of the first page, where it says fill in the blanks below as each term is discussed. Then you're going to go and read the opening sentence there under opening exercise and write down your thoughts on Joe, Marty, and Tony. Think about where they should stand. Should you figure this out precisely, not just guessing, but have exactly an answer that is the answer. And then what tool or tools could you use to get to that? And again, just jot down your thoughts right there on the page. Please spend 10 minutes on this, so pause the video at this point and go and spend 10 minutes doing that activity. Okay, assuming that you spend 10 minutes doing that activity, let's go through what the vocabulary words were. The blank between points A and B is the set consisting of A, B, and all points on the line AB between A and B. So if you've got a point A and point B and you want everything between them, you are talking about the segment. Okay, the segment from the center of a circle to a point on the circle. So if you're at the center of the circle and you go to a point on the circle, you are talking about the radius. So here's a point A, here's a point B, and there's all the points between there. So that's a segment, that's a radius. Given a point C on the plane and a number R greater than 0, the blank with center C and radius R is the set of points. So if we are center C and we want to have all the points that are the same distance, R distance from the center, so you are going to be doing this. These are all the same distance from the center, and you end up with a circle. So the idea here is to get familiar with exact wording and how precise you have to be to really define something. So radius AB means a distance. Notice there's no little segment mark above it. And radius AB with a segment mark means the segment. So this is going to get really technical in geometry here, knowing exactly what you mean to say and saying exactly what you mean. Let's see. So if I have a capital letter A, that's a point. If I have a scripted letter A, lowercase, that's a line. If I have a scripted capital letter, that's a plane. A is the only way to label a point, so that's just a point here. Other ways you could label a line, you could say A, B, 2 capital letters with a line above it, and that would be another way to write a line. And you could say like A, B, C, and write the word plane. So it would be plane ABC, because you could also have triangle A, B, C. You could also have angle A, B, C. So there's lots of different ways you can label things. So a capital letter is a point. A lowercase scripted, that just looks bad. Where's my eraser? And normally we use like an L or T, so let me script a T here. So T would be a line, so this would be line T or line AB. This would be a capital letter plane A. You could also have a capital letter B. So you have to know your scripts and what capital letters and lowercase letters are. And so plane A, B, and C, triangle A, B, C, angle A, B, and C. Okay, so then the next thing I need you to do is go over example 1. We spent about 10 minutes on this. One person from each group is going to have to go get a compass. You need a compass and a straight edge for this. So going to your book to exercise 1, and you'll see that this is about, let's see, Margie had 3 cats, She has heard the cats in a room position themselves equal distance, and so you're trying to figure out where the third cat has to sit. So it's kind of similar to the opening activity, and you're trying to figure out where that third cat has to sit. So spend about 10 minutes on that, and then we'll come back and visit that one. Okay, hopefully you spent 10 minutes on that. If we look ahead at the next activity, we're going to spend 12 minutes on this activity. This is proposition 1. It's Euclid's proposition. We want to try to figure out what it means. And in the margin, you're supposed to compare what he did to what you did with your sitting cats. So take about 5 minutes and read through proposition 1 and see if you can understand it, and then I'll explain it all in detail. Okay, what Euclid's proposition means, it says let AB be a given finite straight line. So let me get a finite straight line, so that would be a segment. Okay, here is a finite straight line. And let me put a point on that. Okay, so there is my construct an equilateral, given a finite straight line. So there's my finite straight line AB. So I'm required to construct an equilateral triangle on the straight line AB. So this is going to be one side of my equilateral triangle, and I'm trying to get my other two sides. So let this circle BCD with center A. So that means my center is A, and BCD is going to have to go through B. So I'm going to take my compass, and I'm going to spread it out here so that my center is at A, like it says, and it's going to go through a point B. And let's change colors here. Okay, so here is circle, and that would be circle B, and then let's grab, and I need a C, and I need a D. C and D. Okay, so there is circle BCD centered at A. And it has a radius of AB. Good. Then we want to circle ACE. ACE. So let me change the color on this and move this over. Notice I'm not going to adjust my compass at all. It's going to stay the exact same width. And I want ACE with center B. So I put the center at B. And I'm going to draw this circle. And notice how they cross each other. And it says it's ACE. So I've got to put C on here also, because it said C was on the green one and C was also on the blue one. And then I need one more point, because it said that this one was ACE. So I need a point E. There we go. Okay, so now I have the blue circle ACE, and I've got the green circle BCD. And notice how they have point C in common. And the distance from A to C is a radius. And the distance from B to C is a radius. And the distance from A to B is a radius. And the distance from B to A is a radius. So if I just take a straight edge and draw this other two segments in, I should have an equilateral triangle, ABC. And that's what that big paragraph is talking about, and how to construct that. So now you can go back to your sitting cats and figure out where the third cat has to be. And you can go back to Joe, Marty, and Tony and figure out where they would have to stand, both by using this Euclidean proposition 1. So take a moment and go back and revisit those two and see if you can figure out how to do this. And if you need to rewatch this little clip here over and over and over again to figure out exactly how I made the equilateral triangle, you could do that. So hit pause and fill that part in. Okay, so if you hit pause and you went back, you could then, let's see, grab the compass. Grab my compass. Okay, and if I put my center on J, and move this across so it touches S. Oh, I just barely make it. And then I could make a big arc there. and then I'm going to put this at S, and I'm going to make my arc go in the other way, and right here, that is where the third cat would sit in this instance. So my calico cat would be sitting on the bookcase, and then all three cats would be equidistant from each other, or you could make an equilateral triangle. So geometry assumptions, you're going to spend 7 minutes here. What I want you to do is quickly read through the assumptions there at the top of the page. So this is, I think, like page 4 or 5 in your notes. Let's see, it's page 4, S4. So read through the assumptions, pause this, and then come back. Okay, so the first assumption, let AB be the given finite straight line. AB be the given finite straight line, so I probably should put a segment tool over top of that. And given any two different points, there is exactly one line that contains them. So this is just an assumption that we can make. If you have 2 points, 1 point here and 1 point over here, how many lines can you draw? Oh, the only line I can draw would be that one that touches both those points. There's no other line that's going to touch both of those points, only one. So there is exactly one line that contains them. And then every plane consists of 3 non-collinear points. So if I put a third point out there, how many planes could I have touch those 3 points? Well, the answer is 1, just the computer screen. I couldn't go at an angle through my computer screen and still touch all 3 of those points. For every pair of 2 different points, there is a real distance. So there is a distance between A and B, as long as they are different points. And so we write distance AB, and if you look here, that is 8 centimeters. See the 8 right there? Okay. So this is just a form for writing distance. You might see that off and on in these workbooks. The distance from A to B is the same as the distance from B to A. So if I take my ruler and I measure from A to B, and then I take the ruler and I measure from B back to A, you're going to get the exact same distance. That's all it's saying. So distance A to B is the same as the distance from B to A. If A and B are the same point, then the distance between them is 0. There is no distance between them if they are the same, and we call the same point coincide. Coincide means the same point. So B coincides with A if they are on top of each other. Okay, every line has a coordinate system, which means if I have a point A, I can say, hey, let's give that a value of 0. Then I can put a B over here, and I can put a C, and I wanted them to be the same distance, so let me spread this out a little bit. I put that right on A, and I do that. Rotate this around and do this over here. Then I can make point B right there, point C right there, and they are going to be the exact same distance from A. Notice that I'm using a lowercase l here to represent the line. So this is line L, this is line CA, this is line AB, this is line BC. Any of those will identify that line. So if I had these two and they're the same distance away from each other, I can say, hey, this is 1 away, and if this is 1 away to B, then it's -1 away to C, going the opposite direction. Just the distance between them is the same. And I could keep going with that distance using my compass over and over again. So distance, just keep drawing arcs. So the distance from A to B is the same as the distance from A to C, which is the same as C to R, which is the same as R to whatever this is, and whatever this is to S. They're all the same distance. But if I wanted to find the distance from S to R, I would take the -4 and subtract the -2. And -4 minus -2 would be a -2, but then we take the absolute value of that, and the distance is 2. And I know you could easily count 1, 2, but sometimes you're going to have really big numbers that are far apart you don't want to count. So the formula for distance is subtract them and then take the absolute value, because distance is considered in math class to be a positive number. You don't deal with negative distance till you start dealing in physics class. And then you've got some relevant vocabulary. So there's a crossword puzzle. You want to do the crossword puzzle. The vocabulary words are all defined here for the rest of the page. So that's page 4 and 5 have vocabulary words defined. And then the homework is the problem set. And there's a ticket out the door to do also. And that gets you caught up in everything we did during the class period.